So hey guys, welcome back to another lecture. So today we're going to discuss something known as the limit evaluation. So until previous we have discussed a lot about the limits, like how the limits are formed and what how we use the limits and a lot of stuff out there. So please check the videos which I have made previously. So today we're going to discuss the limit evaluation. So like how we evaluate. What do you mean by evaluation? Just a kind of judgment to accept, right? So how we evaluate, it means like to determine the value of a function is approaching a certain point. Means like what is limit, like I have telling from the previous lectures, like so it's a kind of a approaching to one point, whatever it may be. It's just approaching, means like from the RHS and from the LHS, it's just approaching from the one point. So it means to determine the value of a function, like we are determining the value of a function is approaching at a certain point. The point means at a certain point the value is approaching, right? So first of all, to find that evaluation, first we need to check the if the limit is continuous or not. So as I already discussed something, what is continuity and etc. So please review it. So we check if the limit is continuous or not. So if you find the limit continuous at a point where we are evaluating it, so if you find a limit continuous at a point, so if you find a continuous at a point where we evaluate it, we simply substitute the values and solve the functions. If we simply substitute the values, whatever it may be, like a 3 here, so we just simply substitute and we solve our functions. If it is not non-continuous, then we cannot define the limit functions, right? This is a non-continuous functions. You can review it in the previous lectures, how what are the continuous and what are non-continuous. It is easy to remember. Okay, so we have a function, right? For example, we have a function like when x approaches 3, we have a x square minus 10. So we in the 3 value here, we just substitute here, and then we get a value of minus 1 here. We not always draw a graph to point, like we cannot draw a graph like this and plotting the points. We have a direct methods. We have a direct methods, like 3 kind of methods for the evaluating of the limits. So what are the methods? So there are 3 kind of methods. So first one is the substitution method. The first one is substitution. The first one is the substitution method, and the second one, which is the factorization method, and the third one is the rationalization method. And we have a common method which we use in our general examples, like by using the calculator and a regular math. Okay, so the first one we going to discuss the substitution method. So what do you mean by substitution method? By the word you can understand what is substitution. Means we just plugging the some values to the function, right? So we just plugging some values to the function. So this is also called as a plugging method. So the substitution method is just if it is a continuous function, means our function has to be continuous, otherwise it is not defined. Okay, so if it is a continuous function, the limit can be obtained by the direct substitution. Means the limit which we are obtaining by the direct substitution, we just simply substitute the values and we get our function output. Okay, this is because by the definition of continuous functions, just review the continuous function, you will get it. Means like we have a LHS, right? If the value at a point A, where x is equal to x, at a certain point here, LHS at a certain point here is equal to the RHS at a certain point, then we can say that it is equal to the f of x, which is our main function, right? So I just clearly explain, like we have a function like limit x approaches 3 and x square minus 10. We just simply plug in our value, means we substitute the 3 in the x and we square it up and we finally get our answer, right? Means like it seems like when limit x is equal to 3 of a function approaches 3 from the LHS, means like from the LHS and the RHS, which is equal to the minus 1, right? Which is equal to the minus 1. This method only work in the continuous, means like if it is continuous only, then it's going to work. If it is continuous only, then it's going to work. Means if it is not continuous, then we have another functions, and we will discuss it later. But if it's continuous only, this will work, otherwise it won't work. So just it seems when limit x approaches 3 of a function approaches 3, when limit of a function approaches 3 from the LHS and the RHS is equal to minus 1, right? There is a note here. This method only works in the continuous, as I said na. So this method only works in a continuous. The substitution method not work in everywhere, because there are some problems that we cannot substitute directly. We have to take some kind of modification to substitute, etc. So for example, if it is a non-continuous function, if it is not non-continuous function, then we cannot directly substitute the values and find our output, right? So I'm going to give another example, like, so I just want to give another example. So we have a limit, right? So we have a limit of x approaches 3. We have a function x square minus 25 by x square minus 4. We just simply plug in the values. So if we plug in the values, what it will be the, so we just have another example, right? So we have a limit x approaches 5, x square minus 25. I just remove this for a simple example. I just want to give a simple example. So x is x minus 5. So we just simply plug in the values in the equation. So it will become like 5 square minus 25 by 5 minus 5. Then it will become 25 minus 25 by 5 minus 5. We simply cancel out these values and the answer will become 0, right? And the answer becomes 0. I hope you're getting it. So what do you mean by a substitution method? We just simply substitute our values. That's it, bro. We just simply substitute the values in our function if it is continuous function. Okay, I hope you have a clear idea about what is the substitution method. And we have the second, which is we have a factorization method. By the word we can understand like the factorization. We use factorization method. So the factorization leads to cancellation of the common factor and reduction of the limit to determine a form. So what is the factorization method? You may ask, like, so how we find the factorization method and etc. Means like I have given example here. Just look at the definition. Okay, so the factorization leads to the cancellation of the common factor. So we just cancel out some of the common factors to find our output. Okay, and the reduction of the limit to the determined form. So I will give you the example, otherwise it will be hard to understand. So I just want to give an example. So we have a limit x approaches 5, x square. I just simply taken the previous example. So how we gonna find the factorization method here? So we have a limit, right? We have a limit. If you clearly observe the value, we can write 5 square. We can write the 5 square means like 5 square means with the value is 25, right? So we can, if you remember the equation like a square minus b square, if you remember the equation, just review it. If what is the a square minus b square, it will be a plus b, a minus b, right? A plus b, a minus b. I just want to plug in these values, right? So I just want to plug in x plus 5 and x minus 5 by x minus 5. So what will be the value? It will become x plus 5. If x approaches 5, then the value it will become 5 plus 5, which is nothing but equal to 10. This is our final output, right? So it's just a simple, like we're just cancelling out of the common factor. Which we have in the determined form. I hope you're getting it. So what is the factorization? Just the research about what is factorization, how it is used in machine learning and etc. Just as of I just want to give a basic idea like it leads to the cancellation of a common factor. Okay, it just leads of a common factor and a reduction of a limit to, it gives a determined form, and we will get our output. Just try it out another examples. You may have you will get a good idea about the factorization method. So we have so actually there are two kind of methods in the limits using the algebra, right? So we have discussed the algebra in a previous lectures, right? So we have a limits means like if the limits are using two kind of methods in the using algebra, which is the one is the factorization and the second one is the conjugate method. So what do you mean by a conjugate function? You may ask, right? So it is formed by changing the signs between the two terms in a binomial. Okay, with respect to the condition that the sum and the product of the binomial and its conjugate are rational. So what is the summary, right? So it is formed by changing the values, by changing the two terms in a binomial function, with means like I just want to change the signs. I just want to make it plus I just want to make it plus. So I will give you an example, don't worry. But as of now, like just I will give you the practical example over here. But it mainly tells about the means, like we just simply change the signs of that and we find our output. Okay, we find our output if the conjugate is rational, if the conjugate are rational. Okay, so our main goal, so what is our main goal? To rationalize the denominator, to rationalize the denominator. This is our main goal, right? So we just want to rationalize the denominator. So if we want to find our output, right? So how we gonna find it? So how we gonna find it? I just simply write the equation over here. And I am multiplying with the changing the signs. I just multiplied with the equation which the first one. I just change its signs from minus to the plus. So if you remember these, we have getting a formula in our mind, like a minus b and a plus b, which we have discussed in the previous example, like a square minus b square. I hope you getting it. So we just simply plug in the formula over here. So what will become it? A square minus b square by, if we multiply these two, I just want to multiply these two. Okay, I just want to multiply these two, but the square got cancelled and it will become x minus 4, and we have a denominator, right? We have x minus 4 and root x plus 2. We just simply cancel it out and we will get our output as a 1 by root x plus 2. If we substitute our value, which is 4, it will become root 4 plus 2. What is the root 4 value? What is the root 4 value? It is 2. So we get our output as a 1 by 4. This is our output, right? So we just simply finding the output by multiplying with these duplicates, which we change the values, we change the signs of that. And if why are multiplying means, like if we add plus, then it will change the equation form. Okay, so we just multiply. If it both cancel and it is equal to 1, and if it 1 is equal to and the value is the same. I hope you're getting it, why we are multiplying it. We just simply opposite of this sign, we just simply change our sign and we just simply do the calculations over here and we will get our output. Okay, so after that we have a rationalization method. So what is rationalization? It rationalizes. The rationalization of an intermediate expression leads to the determined one. Means, like, so the rationalization, it rationalizes the equation. It rationalizes the equation of an intermediate expression leads to the determined one. So it will give the intermediate expression to a leads to a determined one. So I just want to give an example so that it will be easy for you. Okay. So we have a limit x approaches to, and we have a x square plus 1 minus 1, and we have a x square plus 16 and minus 4. So we just simply, means like we take this value, we just simply multiply with this value. And I just want to take in the conjugate method, what we have taken the numerator, right? We just multiply with the numerator only. In the rationalization, we multiply with the denominator also. So here we multiplied with the numerator and we multiplied with the denominator. I hope you're getting it. We just simply multiply with the numerator and we just simply multiplied with the denominator. And if we cancel it out, and you are going to get our output as a 4.5. It is 4.5, which is almost equal to the 4.447. It is 4.5, approximately equal to the 4.5. Okay. So it is just a bit of advanced, but practice makes perfect. So I just want you to explore it out on your own so that it will be easy for you when we run the programming. So I just want to do all these in a programming lectures. Don't worry, it will be easy for you if you have a basic idea and a basic intuition that how these gonna multiply. And we just simply write the equation, like we have a theta and we have a theta transpose and we have a dot product. We just simply write whatever it may be. We just simply write in the one line and we will get our output. We are doing like 1 2 3 4 5 6. We are doing the 6 lines of calculation, right? So we are doing the six lines of calculation, but in the Python we just simply write in a one line and our get our output in a fraction of seconds. But if we do by hand, we may get our outputs, we may get a calculation wrong, which may lead to a wrong output. right? So I just want to know, I just want to know, that's it. I didn't want to be master in the calculation. I just want to know that if you have a basic idea, and it will be easy to tell in a programming like what is going to be happen and etc. So we have covered all these three, right? So what we have covered, we have covered the substitution method. So what is the substitution? We just simply substitute and plug in our values and we'll get our output. So what is factorization? We just factorize the value, and we have a conjugate method. We just simply multiply it with the by changing the values. And we have a rationalization. What is rationalization? We just simply multiply with the numerator and we just simply multiply with the denominator, and we get our output, okay. So I just said now we have another method like by old method, by using a regular math, with the help of the calculator or whatever maybe. So I just want to give a formal example, so it will be easy for you to understand. So by using the regular math problem, so we have a, so just ignore this equation. We have a, this equation, okay. We have a this equation. So I just want to plug in the values from the LHS, and the RHS. So I just want to plug in the values for, from it is 5, right? So I just want to plug in the values like 4.999, 4.9999, and 5, and 5 point, and 5.001, and 5.0001. So I just want to plug in these values, and I want you to find these outputs. It's just a simple kind of stuff. We just simply plug in the values here and we will get our output, okay. So we just simply get our output as a 9.998, 9.9999, undefined. It will become undefined, and it will become 10.001, and then 10.0001. It approximately equal to this value. So if we conclude that, we conclude from the, we conclude, right? If it is, if the equation from the, if the equation from the LHS is equal to the, from the, from what, from RHS. So if this LHS equal to the RHS, then we can say our limit, then we find our output if it is continuous, okay. I hope you having a basic understanding, right? So if you don't understand, so please review the previous lectures where I talked about this table, where I talked about this regular math problem in a great detail way. So I just want to review the previous lectures, so where I explain in a great detail way. So I just wanted to preview the previous lectures, so if, so that you can have a better idea. So how we plug in these values, like what is 4.9 and 4.99, etc. We just simply closing from the LHS and RHS. So please review that. You will be, it will be easy for you to understand, okay. So next we're going to discuss squeeze theorem. So what is the squeeze theorem? So it is also called as a sandwich theorem. So it is used in calculus and a mathematical analysis, typically to confirm the limit of a function via comparison of two other functions. So if we have a three functions, typically we confirm the limit by the comparing these two functions. So if I have 1 2 3 function, we just compare 1 and 3, and based on these two we give our output, we just give our decision on the two. I think it makes sense. So if it says like, if we have a f of function, f function, g of x function, and we have a h of function. So if there are three functions which are continuous for all numbers, and at some point, like if the x is equal to k, which is a constant. So if we have a constant, whatever it may be, the 1 2 3 etc. So if these f of x and h of x is equal to, then we can say that this g of x is equal to the these two also. So if we have this, if it, the value will become the 10, and these values are also 10, then we can directly say from this theorem, we can say that the g of x value will become also 10. Okay, I hope you're getting an idea. So we have a great diagram over here, so it will be easy to understand. So like what? So there are three functions. There are three kind of functions, okay. So we have a f function, we have g function, and we have a h function. Based on this f and h, we gonna make decision on the g. So they are intersecting at some point, right? 4. They are intersecting at 4. So the g function, which is the sandwich below by the f and h. So what is the What is the shape of the sandwich? Right, this is the shape of the sandwich, right? So I never tasted it. So how it will be the taste, I don't know, but this is a sandwich. This is a sandwich, right? So there's a lot of there are stuff here. So this is a sandwich. So we're gonna say that it may be a tomato here. So this is a bread, this is a bread, and these both are called as a, so this tomato is just a part of the sandwich. Yes, this tomato is a part of the sandwich. So this G is just part of the F and the GF. So it's just a G function is sandwich below the F and H. If they both are equal, then we can say, if they are two are breads, then we can say this is our tomato which we used in our sandwich. So we can make decision. We can make a decision on the G based on these two, right? So if these two are breads, then we can say it's a tomato. If these are not two breads, the first one is bread and and another one is a butter or chicken, then we cannot say if it might be a tomato but it's not tomato. I hope you're getting a good idea. So, or if it is like another stuff, whatever it may be, if it is a plate or down here, and it's a plate down here, and we have a something over here, and if it is the cover, then we cannot say it is a tomato, right? If it is a burger, if it is a sandwich, then we can say that it is a tomato, right? If these two are equal, then we can say we can make the decision of G. I hope you're getting it. So if we have a function, we have a three functions. If these two are equal, means like g of x also will be equal to the constant. So here the k is 2, okay? So which is equal to the 4, means like from the limit f of x, g of x and h of x is equal to 4, all are approaching 4 by the diagram you can see, right? So by the diagram you can see, like, so I hope you have a basic understanding like what is the sandwich theorem. So we just find the one function with the help of these two functions, okay, which is the middle. We just want to find this function with the help of these two. I hope you have a basic understanding. So next we going to discuss, we have a great detail way. So I just want to discuss in a great detail way. So what is differentiation? There is a lot of notes here. It is a 40 pages of notes here. So I have written a long notes, beautiful notes. So I hope you love this and support this channel. So until then, bye bye, see you in the next lecture.